All right, today we're taking a look at day 12, which is composition of transformations, also describing similarity and congruence transformations in words and using their properties to kind of answer questions. So take a look at, remember from yesterday, the last video we talked about was going through and doing rotations and reflections and the rules. So we're going to be kind of pulling those into today's. All right, so number one, when you're describing a transformation, remember that a translation, you're just going to describe that you're doing a translation. So translate what shape. You're going to give the ray. So just pick two corresponding points like A and A prime, and then you're going to draw the little arrow over it to indicate what ray you're moving along. And then you're going to end with so that it maps onto what shape. When we rotate, we're going to rotate some shape around either clockwise or counterclockwise around a point. Make sure you write out and not abbreviate on the exam. And then same thing, so that it maps onto what? For a reflection, you just need to say that you're reflecting a certain shape over a line. You don't have to end with the so it maps onto part. And then a similarity transformation is going to be a dilation. So when we do a dilation, we always want to mention that we're dilating what shape by some scale factor k, by some number, and then what is it centered at? What point are we keeping still? Are we growing or shrinking towards? Okay, and that, remember, we can use either side lengths or perimeters or altitudes to create our scale factor. And remember that if I want to get bigger, okay, then my scale factor needs to be the big over the small in terms of the corresponding sides. And if I want to get smaller, then we're going to put the smaller side on top and do small over big. So think about like the number 2/3, right? 2/3 is going to make something shrink because you're doing 2/3 of something. But if we flip it upside down and do 3/2, it's 1.5. It's going to grow. Okay, so keep thinking about like those numbers, like a third or 3, shrinking by a third or growing by a factor of 3, the reciprocal. And when we want to get bigger or smaller. Okay. For question number 1 here, we want to, given the set of axes below, we want to describe a sequence of rigid motions. This means an order of transformations that is going to map the first triangle ABC onto triangle DEF. Now, there's a few different ways to do this. We ultimately want to notice that the triangle is pointing, kind of say that it's pointing left here, and it's going to shift to pointing to the right. So we're going to have to do some sort of either rotation or a reflection to get that to happen. So there's a couple of options here. We can rotate, we can turn this triangle, okay, and it's going to be 2 quadrants. So it's going to be 90, 180 degrees. Point A, when it shifts, is going to rotate down here. It goes from the point -3 to 3 to 3, -3. B is going to be 3 units below, and then C is going to be 4 units to the right. So if we rotate 180 degrees, we're going to get this triangle right here, and then I just have to shift this triangle up. Now, when you're doing a transformation, you're describing it in words, you just want to end stuff with like rotate 180 degrees about the origin. Or we might say like reflect over an axis, or translate 6 units up or down. So you can use those directions and those numbers on a graph, where if we look at the question right next door to this one, we can't, and we'll do that one next. So we're going to write this one up. So notice the first thing we said is we're going to first, because it's an order, it's a sequence, not first. All right, let's try that again. All right, we're going to say rotate triangle ABC. Now we want 2 turns to get down here, so that's 180 degrees, and we turned it around the origin. Now you can either say origin like this, or you can say the point 0, 0, so it's your call. And then, that's a little comma there. Now all we have to do is take this triangle and we need to shift it up. And we want this point to go up 1, 2, 3, 4 units, to go up 4. Okay? So that's it. So then, translate triangle ABC. And we're using ABC because that's the original shape that we moved. We rotated here. Now we're just shifting it up. Okay? Up, we said 4 units. And we're done. That's it. Okay, you also could have did this a different way. So if you thought about it for a second, You could have reflected this triangle over the y-axis, right? And got B to go here, A to go here, and C to reflect over here. And then all I have to do is use another reflection, and notice that the mirror is actually going to be this line right here. And this is the line y equals 2. Okay, so that's another option. Or we can reflect over the x-axis and end up down here and then just shift up forward. So either way, you could do a reflection and a reflection, or a rotation and a translation. Both will work. Okay, for the triangle on the right, key thing we want to keep in mind here, okay, is we want to make sure that we get the triangles to overlap somehow first, whether you have them share a point or a side, and then do a rotation. It's a lot easier to describe that way. So if we think about this triangle here, okay, we might say to ourselves, all right, self, I want point A, which angle A is congruent to angle D. I'm going to move this triangle, all right, so that this point is going to shift and overlap point D. I'm going to move that and make that happen first. Okay? So what I did was I took and translated point A over to point D along that ray. So that's what we're going to do first, and that's how we're going to write this up. So remember, we're doing a sequence. We need an order, so we're going to say first, not first, but first, okay? Translate. Now, because of the wording here, it says we want a sequence of transformation that maps triangle ABC onto triangle DEF. So we're going to translate ABC, because that's going to be mapping onto, all right? And we're going to say along, and we don't need to write the word ray. We can just use our symbol for ray A, not B, but B. Now, we're sliding along this line. We also have to tell people when to stop sliding. So we can say until or so, right? A maps onto D, until something maps onto something. Okay, boom, we hit there, and now we stopped. Second thing we're going to do is, because we want AC, right, which was this side, to be congruent to this side, okay? And AB and DE are going to be equal. We're going to just spin this now, not reflect it, but spin it, okay, over that, around this point, so that these triangles now overlap. So now then we're going to say either second or then, so there's an order. All right, we're going to rotate triangle ABC. Now, because I don't have like a graph, I can't just say like how many degrees. So we're going to say rotate triangle ABC. We're going to say clockwise, so we need a direction. We need a center. So remember, we're currently on top of point D, so around D. And then when do we stop rotating, until, and we can get this point, right, which was B, is going to end up on E, until B maps onto E. Okay? Now, you could have said, so the triangles overlap, or B overlaps E. Any of those things will also be fine here. All right. Heading down to number 301. So once again, try this one on your own, and then we'll take a look at the answer. All right, and hopefully you came up with the fact that we need to do a translation and a reflection. Now, it doesn't matter the order you put them in, but we want to translate 6 units to the right, and then we're going to reflect over the mirror that is the x-axis here, okay? If you reflect it over the x-axis first, that'll put you over here. And then all you have to do now is just shift over to the right 6 units, okay? And you could just count the number of spaces as the number we want to move. Now, keep in mind, be careful of the way this is ordered. Do you see how the kind of triangle is kind of pointing to the right here? If we did a rotation, that would actually flip, and we would be going to the left. So be careful that you pay attention to the way the letters are ordered, to know whether or not we're doing a rotation or a reflection. So once again, as long as you wrote down that you did a reflection over the x-axis and then translated triangle ABC 6 units to the right, you would get full credit no matter the order there. All right, try 303 next. Okay, so on this one, you should have given an order of a reflection over the y-axis and a translation of up 2 units. So if you decide to translate first and then reflect it over the line, that is fine. Okay, keep in mind it's not just a translation and a translation. And ooh, be careful. If you notice, we were supposed to move triangle ABC onto A double prime, B double prime, C double prime. I did this in the wrong order. So when you're doing this one, instead of going reflection, we still want to go, instead of going up, we actually want to go down, okay? Down here. Because we don't want to go in this order. We want to shift this graph down 2 units first, and then shift it to the left. So we get triangle ABC go on to A prime, B prime, C prime. So a reflection over the y-axis works, and then shifting down 2 units, or going down 2 and then reflecting over the y-axis. All right, let's see if you can try 304. We'll do this one together. 304, when we're looking at this question, is we're doing a similarity transformation. So the first thing we're going to have to do is talk about the fact that we're doing a dilation. Now, when we grow or shrink this shape, point A is staying the same. So this is going to be our center. So we're going to say dilate triangle ABC. And the reason I want to do that is I want to map ABC onto ADE, okay? We need a center, so centered at A. And then what are we multiplying it by, right? What are we going to multiply this by? Now remember, we want to get bigger, and all I have to do is just pick 2 corresponding sides. So I have AC in the small triangle ABC, and that corresponds with AE in the larger triangle. So we can say that we're dilating it by a factor of AE over AC. And instead of this, you could have also done, right, DE over BC, or you could have done AD over AB. And it says, explain why the transformation makes it similar, okay? And you could have said anything about the fact that a dilation, okay, changes the side lengths, but not the angles. All right. So the triangles are similar is fine. That's one way to say it. We could say that these lines are going to be parallel, and therefore the angles are congruent and they're similar by AA. Any one of those things would also be an okay explanation here. All right, 309. So in question 309, once again, we can see that we had 2 triangles, okay, that DEF is the image of ABC. After, and this is important, a clockwise rotation of 180 and a dilation. So because we're doing a dilation, we know that triangle DEF is going to be similar to triangle ABC. So we can automatically know that the side lengths, that the angle measures are going to be equal. So angle F, right, which is in between these 2 big and small sides, is going to be the same as C. That D is going to be the same as A. And that B is going to be the same as what should be an E over here. Okay? So if we look at these, we know that 1 and 2 can't be the same because we shouldn't have a ratio of 1/2 or 2 to 1. This means that the angles are not equal. One's twice as big as the other. And then for 3, we just want to match up. Is A over C, right, A over C, the same as F over D? And you can see, like, this is 2 arcs to 1 arc, this is 1 arc to 2 arc. So this is actually upside down, so that's out. So we should be choosing choice 4 because B over E, right, small to big, is the same as C over F, small to big, and that works. Okay, and then in number 314, triangle ABC is the image after a dilation followed by a translation. This is important again, which would be true with respect to the sequence of transformation. So, key thing here, if we take a triangle, okay, and we translate it down here, and then we make it grow by some scale factor, okay, into a new shape. Are these lines parallel? Yes. Are the triangles equal? No. Okay? They are similar. So we know that this is true and this is true. And this is also false. It's not always true, because if this point A becomes this point A prime and B goes to B prime, the distance between A to A prime is not the same after the dilation as B to B prime. Okay? It would be after the translation, but not the dilation. So we now know, okay, that it has to be choices 2 and 3. Now, process of elimination is a great way to answer these questions. So if you know that 1 is not the correct answer, you can cross off any answers with 1 in them. If we know that 4 is not a correct answer, we can get rid of anything with 4 in it. And then we have to decide whether or not it's either only 2 or includes 2 and 3. And this one does include 2 and 3. All right, this will be part 1 of 2 videos here. So you can watch the next video, which will cover the next 2 pages. And these pages are also due for homework tomorrow. All right, have a great night, and be on the lookout for part 2.